Alright, in this video we're going to start off our connections and connectivity with getting, let me do this real quick and get rid of send commands because I don't need that. Give myself a little bit more real estate to work with. That should work. So the first thing we're going to do is we're going to get OSPF running in the core. So 6 through 11 we're going to get OSPF running in the core on all links. Well, actually all routes internal to the that's what we're gonna do. So our first thing first, we're gonna type in now. I'm just thinking here as I'm going along. Here's what we're gonna do. We're going to make the VPN full mesh of VPN v4. I'm gonna add a piece in here, and I'm gonna say we're going to say that. I'm trying to think of how to word it. Ensure VRF configurations will support IPv6 growth natively. So that should be an indication to you that we need to use VRF definition and not VRF IPVRF. So that's going to be another one, and that's going to be that natively, and we're going to say OSPF in the core. OSPF in the core. Yeah, that'll be fine. I don't want to get super specific. So what we're going to do is we're going to type in router OSPF 1, and now technically speaking, I could use OSPF v3 here and run with it, but I'm going to do a specific OSPF v3 section and an EIGRP v6. So eventually we'll do an entire OSPF v3 section. Same thing with EIGRP. So we'll run both v4 and v6 at the same time, and we'll run MPLS with IPv6 as well going down the road. But these will all take some time to get operational. So for right now, I'm just going to use regular OSPF, and then I'll come back and I'll do an entire OSPF v3 section and go from there. So I'm going to type in network, and I'm going to specify the links. I'm going to use the network statements that are specific to the links that I'm advertising it on. So 10.1.106.0. and I'll do 116, and also do 67. So that gets me that, and now I'm also able to do from here. You could either type in MPLS IP at the interface level, or what I'm going to type in is MPLS LDP autoconfig. That's going to turn MPLS on any interface running OSPF. So that's why you got to be kind of be careful with this. Actually, let me bring this over here. Actually, I need to put OSPF on this link tier too. So I need to type in network is gonna. You know what? Just thinking. I can't use MPLS autoconfig on this router, and the reason why I can't use it is because of the fact that I'm going to have I don't want to run MPLS on the circuit. I can't run MPLS on the circuit because it's going to be a PE to C route. So I have to use no MPLS autoconfig. So I'm going to type in network is going to be 46.0.0.0, and it says Atom Trans 6 no router. Okay. That's 0.0.0.255 area 0. Now, I don't know if you guys are familiar with this, but anytime you're running OSPF as a PE to C protocol, there could be some some hinkiness that can run with that. So right now we've appeared with router 4, so if we were to type in do show IP route, we should have some OSPF routes learned. Now, we haven't redistributed anything from EIGRP into OSPF, or OSPF into EIGRP, and we'll take a look at that coming up later on, because there is specifics you need to pay attention to. I'm going to be spending quite a bit of time in a redistribution section as well, covering, if we receive a route in, this is where it would go, how that would actually pan out, things like that. So, I can't do MPLS on that interface either. So on router 7, let me go to interface gig 1.16. Type in MPLS IP, and then 106, and then 67. Now the reason why I'm doing it like this is so that I'm enabling LDP as I'm configuring OSPF, because you need to have OSPF running before you can run LDP. Well, you don't have to, like I said in a previous video, you don't have to run an IGP. You can run static routes, but it's not going to scale, and it's not going to fix itself if it breaks. So I'm going to go to router 7. I'm going to go to global config. I'm going to type in router OSPF 1. I'm going to type in network is going to be 57.0.0.0, 0.0.0.255 area 0. So that's going to give us our OSPF PE2C routing there. And then I'm also going to type in network is going to be 10.1.67.0. Get that in there. And then I'm also going to type in 107 and 78. And that should be all I had to type in. I'm going to go to interface gig 1.67, MPLS IP, and 107, and then 78. Now I should form an LDP adjacency here momentarily. Now the kicker with this thing is, in order for LDP to work, you need to have the loopbacks advertised. Now that's one thing I haven't done yet. I don't know if you guys noticed that or not. I did not advertise the LDP adjacency in. So now what I'm going to do is I'm going to go to the loopback interface. What I'm going to do is I'm going to type in passive interface is going to be, router OSPF 1. Type in passive interface is going to be loopback 0. And I'm going to type in interface loopback 0. Type in IP OSPF network is going, 1 area 0. What this does is it advertises OSPF OSPF on the loopback, but it doesn't allow you to send hellos out it. So now I'm going to do the same thing on 7. I'm going to type in router OSPF 1. Passive interface is going to be loopback 0. I'm going to type in interface loopback 0 and IP OSPF 1 area 0. And so now we should form a LDP adjacency here momentarily. So I was typing do show IP route OSPF. I have the 6 network there. And here in just a minute, I should get the LDP adjacency up. Alright, so I can ping it. How come it's not coming up? Let's see if taking the passive interface has anything to do with it. It shouldn't. Let's keep on trucking here. We're going to type in router OSPF 1. Network is going to be 10.1.0.0. 0.0.255.255, area 0. Now, I can get away with this because of the fact that I'm going to be running BGP between 14 and 8 on the 148 network, so I can get away with that. And we're going to type in MPLS LDP autoconfig. So I should be able to form a neighbor adjacency on that guy. Let's go back to 7. Yeah, that LDP adjacency never came up, so I'll type in interface gig 1.78 and type in MPLS IP. I don't know if there's any difference between using the global process versus the interface level. Shouldn't be. Do show IP interface brief. Well, the route is there. There's no doubt about that. What's 6? Show MPLS LDP neighbors. Interfaces. Oh, that's why. Right there. Show run pipe include interface pipe MPLS IP. That's because I only have an on that. That's why. I didn't turn no IP domain lookup on. That's my bad. So yeah, it's the reason why it's not coming up is because of that. So 7 should have an LDP adjacency now too. So let's do a somebody here show run pipe include interface and MPLS IP. What's on that one? What about 8? Why is it not forming? A little bit concerning. Hopefully that'll be the last one. Okay, so go to global config, interface gig 1.67, and MPLS IP. There it goes. That's the way it should go. 7 gets it to the 6, but how come 8 doesn't do it? I formed a pairing with 7 on its loopback. Oh, that's why. Haha. Because I advertised 10.1, not 10.100. Config T router OSPF 1 network 10.100.0.0.0.255.255 area 0. That's why. As soon as I advertise the loopback and there's a peer to it, it should come up. And it does. So that's it's one of those things where you have to know what you're doing before you do it. And clearly I wasn't doing what I was supposed to be doing. And router 9. So now I need to go to router 9, config T, and let's just scoot this guy over here a little bit. And router OSPF 1, and type in network is going to be 10.1.0.0, and then 100. And MPLS LDP autoconfig. So I formed my neighbor relationship, and then momentarily here I should form an LDP adjacency, which I do, which is a good sign. And then we're going to go to 10, which will bring this down, and go to 10, and we're going to go to global config, router OSPF 1, network 10.1.0.0, 0.0.255.255 area 0, and do the loopback as well, and then MPLS LDP auto config, and I got all my LDP adjacencies up, and then 11. Now there's a question. You just did the 10.1 and 10.100 for OSPF. What about the 10.1.103 and 10.1.112 for EIGRP? That's fine. The reason why that's fine is because the fact that when I go to set up EIGRP, I have to be that much more specific. So the idea behind the process when you're doing a dynamic routing protocol and you're going in and you're going to enable a routing protocol which will cover all the interfaces, what's going to end up happening then is if you add another routing protocol, in this case we're going to add EIGRP here in just a second, to connect to R10 to R13, you have to make sure that that network statement is that much more specific to the interface you're going to be putting it on. It'll still work, and I'll show you here in just a second. So we're going to type in router EIGRP, and we're going to hit, we'll type in 1013, so for router 10 and 13. We'll type in network, and by default we're in 15x code, so no auto summary is needed. No auto summary is not needed. So network is going to be 10.1.103.0, 0.0.0.255. So that's where we're going to go there. So that'll start sending EIGRP hellos out this interface. So now we're going to go over to 11, go to global config, type in router OSPF1, type in network is going to be 10.1.0.0, 0.0.255.255, area 0, and then the 100 network. So that forms that. I'm going to type in MPLS LDP auto config. So that gets that going. So we should form our LDP adjacencies, which we do, which is a good sign. I'm also going to do the same thing on R11. I'm going to type in router EIGRP 1013, because we're going to be in autonomous system 13, or 1013. And I'm going to type in network is going to be 10.1.112.0 255, and then I'm going to go up to 12, and I'm going to go config T router EIGRP 1013. I'm going to type in network is going to be 10.1.112.0, and I should form an EIGRP adjacency there, and I do. And then we're going to go to router 13. Config T router EIGRP 1013, and then network is going to be 10.1.103.0, and then that gets that peering up here momentarily. Alright, so there must be an issue here. Show IP interface brief. Alright, so I have the IP address here, so let's do a show run interface gig 1.103. Usually it's an encapsulation issue. They're both there. That'll take that down. Sometimes it's just better to bounce the interface. First line of defense here, make sure it's actually up and operational. Alright, so they're up. Show CDP neighbors. Oh. Nothing yet. So that's alright for right now. I'm not going to worry about that because we're going to be moving that interface into a different VRF anyway. So now that we got that, so we're going to go to router 10, and I'm going to do a show MPLS LDP neighbors. Alright, so we got a bunch in here. So we've got router 6, we've got router 7, we got router 8, 9, and 11. So we have all of our neighbors where we need them to be in MPLS. So that's a great sign. Now remember, this is full mesh, so we have a full mesh of LDP adjacencies set up. The next thing we're going to do is, now that actually knocks out two pieces. We've knocked out both OSPF in the core and IGP and LDP in the core. So the next thing we're going to take a look at is going to be doing full mesh IBGP. Now, we're going to do this in peer groups, because just the amount of configuration that there is, because it is definitely a possibility in the CCIE lab where they tell you to configure BGP but do not use a peer group. There are other ways of doing that with a template, but I've never really played with a template before, so I'm going to do just a massive BGP configuration. It's going to be all IBGP. The update source is going to be loopback 0, and we're going to go off of that, and then that's going to get BGP operational. Now, with that being said, though, I don't need all 6 core routers to run IBGP. Why? Well, the main reason why, and you might be thinking, well, yeah, you do. You're going to have all these routers connected to each other. Well, I do need BGP. There's no doubt about that. But why would I not need to do a full mesh? Well, the answer to that question is I can choose a single router and make them a route reflector and do a route reflector client on all the for all its peerings. But I don't need to do a bunch of IBGP and then VPN-v4, right? All I need to do is do a bunch of VPN-v4. Now you might be asking, why do you just need to do that? Well, the reason why I only have to do that is because of the fact that I'm going to be just peering with that BGP for the PE to PE protocol to exchange the the route distinguisher information, all of the extended community values, the route target values, all that good stuff. So that's kind of the reason why we don't do a BGP free core. We don't want to have every router having to run BGP if we don't have to. So we're going to be running BGP anyway because of the setup, but this is full mesh. So we're going to be practicing it anyway. So we're going to set up a peer group and we're going to just go crazy with that. But I'm not going to do that in this video. I got the IGP and LDP configured, and that was what I wanted to do. So we're going to do we're going to finish this video now, and then in the next video we're going to get into the BGP configuration. So I hope this has been informative for you, and I'd like to thank you for viewing.